Hello student, up to this we have learned that is up to Einstein's postulates of quantization of energy and the photoelectric equation. This we are taking today. Up to this we have completed this chapter. Today we are going to see this article number 14.2.4. That is the Einstein's postulates of quantization of energy and the photoelectric equations. And today we are going to complete this chapter. Yes, that is the Einstein's postulates of quantizations of energy and photoelectric equation. Einstein's proposed light behave as a particle and its energy is released or observed in bundles or quanta with energy E is equal to h mu, where this mu is the frequency of light and h is Planck's constant. H is the Planck's constant having the value 6.626 into 10 raised to minus 34 joule. Therefore, it may be noted that just 1 minute. Where this h is equal to h nu as per the Einstein's postulate, that is the in this case, or when we are taking the radiation, that means the energy in the form of photons, and that amount of photon energy is equal to h mu, where this mu is the frequency of light and h is the Planck's constant. Now this relation between a particle like property and the energy E and a wave like property, that is the frequency mu. Now see the equation, this equation, that is the E is equal to h mu. This equation is known as the Einstein's relation. This equation is known as the Einstein's relation. Now see the Planck's hypothesis of energy quantization to explain the black body radiation was extended by Einstein's. And Einstein's proposed that under certain condition, this light behaves as if it was a particle and its energy is released or absorbed in bundles of quanta, that is this h mu, and he named the quantum energy of light as photon with energy E is equal to h mu, where this mu is the frequency of the light and h is constant defined by Planck in his model to explain black body radiation. It is now known as a Planck's constant, and now this constant is named as a Planck's constant. In this way, he find that the relation between this, that is E is equal to h mu. Einstein's relation holds good for the entire electromagnetic spectrum. It says that energy of electromagnetic radiation is directly proportional to the frequency and is inversely proportional to the wavelength. That is, we know that the equation, that is the V is equal to C mu lambda. That is this equation, we know that, and hence high frequency radiations mean high energy radiation, and alternately short wavelength radiation means high energy radiation. Once again, see what I say. Hence high frequency radiation म्हणजे जे हाय फ्रिक्वेन्सीचे रेडिएशन्स आहेत त्याचाच अर्थ काय आहे, हाय एनर्जी radiation, आणि अल्टरनेटिव्हली शॉर्ट वेवलेंथ radiation means high energy radiation. Okay, now see the explanation using Einstein's postulates of quantization of energy for the observations mentioned in following way. Now, first postulates, a photon, that means Einstein argued that when a photon of ultraviolet radiation, that means when this ultraviolet radiation arrives at the metal surface and collide with an electron, See, we know the basic process of photoelectric. Remember or recite it once again in your mind that when what happened in photoelectric effect, that means when this metal surface under the ultraviolet radiations, then they collide with an electron. It gives all of its energy h nu to the electron, and the energy is gained by the electron and the photon no longer exists. एकदा ह्या फोटॉनने आपल्याकडची एनर्जी इलेक्ट्रॉन्सला दिली की त्यांचं जे अस्तित्व आहे, एक्झिस्टन्स जो आहे तो काय होतो, संपतो. दॅट मीन्स फोटॉन नो लॉंगर एक्झिस्ट. इफ फाय नॉट is the work function of the material of the emitter. What is meant by phi naught? Phi naught is nothing but the amount of energy. With the help of that energy they exit or release from the metal surface. Such type of amount is called as the work function, and it is denoted by the symbol phi naught. Then electrons will be emitted if and only if energy gained by the electrons is more than or equal to the work function, and that is this h nu is greater than or equal to this phi naught. Thus a minimum or threshold frequency, that is mu naught, which is equal to phi naught divided by h, is required to eject the electrons from the metal surface. Therefore, a photon, that means this h mu is must be greater than this phi naught. म्हणजे जेवढी काही एनर्जी मिळणार आहे ती जर फक्त वर्क फंक्शन साठीच वापरली गेली तर कायनेटिक एनर्जी ती जी आहे त्यांना मिळणार नाही, आणि त्यामुळे ते कलेक्टर प्लेट पर्यंत जाणार नाही, आणि ते कलेक्टर प्लेट पर्यंत गेले नाही तर काय होणार आहे, करंट वाहणार नाही, करंट त्या कंडक्टर मधून जाणार नाही. Thus a minimum or threshold frequency mu naught, which is equal to phi naught. With the help of this, we make the equation phi naught divided by h is required to eject electron from the metal surface. Therefore, the exchange of energy between the photon and electron is instantaneous process. That means when this energy is given by the photon to the electron, as soon as the radiation is incident on the surface, and the exchange of energy between the photon and electron is taken place, and this process is what this process, that is the instantaneous. That means there is no time lag between the incidence of light and the emission of electron. Also, when the incident radiation is stopped, then what happened? There are no photons to transfer the energy to electrons, and hence the photo emission stops immediately. Then third point, according to Einstein's proposition, if the intensity of incident radiations for a given wavelength is incident, there will be an increase in the number of energy, that is the quanta. Quanta is nothing but the photon, and incident of unit area in unit time. The energy of each quantum being the same, that means h mu is equal to h, what is this, c divided by lambda, that is the c divided by lambda. H mu is equal to, we know that mu is equal to c divided by lambda. Therefore, we make the equation that is h mu is equal to, again, which is equal to hc divided by lambda. And therefore, the point 3 is, therefore, larger intensity radiations will knock off more number of electrons from the surface, and hence current will be larger. केव्हा पण तो this mu is must be greater than this mu naught. In each and every time, remember, the frequency must be greater than your threshold frequency. At that time, this energy, that means the electrons, are knocked out from the metal surface. Conversely, lower intensity implies less number of incident photons, and hence less number of ejected electrons, and therefore lower the current. once the electrons is emitted, that means emitted from the surface, if the collector is at a higher potential than the emitter, okay, for this fourth point is what, जेव्हा ते इलेक्ट्रॉन हे जे आहे इमिट होतील फ्रॉम द सरफेस, मेटल सरफेस, इफ द कलेक्टर प्लेट जी आहे इज एट अ हायर पोटेन्शियल दॅन द इमिटर, then what happen, the electric field will accelerated the electrons टुवर्ड द कलेक्टर, म्हणजे ते त्यांना काय करणार आहेत, मॅक्सिमम फोर्सने आपल्याकडे घेतील. हायर इज द ऍक्सेलरेटिंग पोटेन्शियल, मोर विल बी द नंबर ऑफ इलेक्ट्रॉन्स रिचिंग द इलेक्ट्रॉन्स प्लेट, and hence the photocurrent I increases with accelerating potential initially, and then the current increases and it reaches its maximum value, and then moreover, since the intensity of incident radiation determine the number of photon incident on the metal surface on unit area in unit time, it determines the maximum number of electrons that can be knocked off by the incident radiation. And hence, for a given intensity, increasing the accelerating potential can increasing the current only till all the knock of electrons have reached the collector. No increase can be seen in the current beyond that limit, and that limit, beyond that limit, and that maximum current at that time is called as the saturation current. That means the current still then remain constant. Now the fifth point, if you increase the intensity, incident intensity will increase the number of incident photons and eventually the saturation current. That means this fourth point and these 5 points are related to each other, related with each other. If the frequency of incident radiation is more than the threshold frequency, that means if this frequency is increased greater than this threshold frequency, then what happened, this phi naught is used. This phi naught is used, that is this phi naught is used by the electrons to escape from the metal surface, and remaining energy of the photon becomes kinetic energy of the electrons depending on the energy of the electrons. And here this kinetic energy, that means this phi naught is the energy which is required, म्हणजे टोटल एनर्जी जी आहे ती h mu इतकी आहे आणि त्यापैकी वर्क फंक्शन साठी एवढी वापरली तर जी काही एनर्जी राहील ती उरलेली जी एनर्जी आहे ती इलेक्ट्रॉन्स काय म्हणून वापरणार आहेत, they can consider their kinetic energy. That means Ke max is equal to h mu minus phi naught, and this is the equation, and that equation is called as the Einstein's photoelectric equation. This is very important equation. Depending on the energy of the electron inside the metals and other processes like as the collision after emission from the surface and the maximum kinetic energy, therefore which is equal to h mu minus phi naught. Therefore finally we say that Ke max is equal to h mu minus phi. In this way, where this equation, from this equation we can say that this Ke max, that is the maximum kinetic energy, depends on the material of the emitter plate and varies linearly with the incident frequency mu. It is independent of the intensity of the incident radiation. And now move towards the 7th number, observations of Einstein's postulate, that is the electrons that are emitted from the metal surface have different kinetic energy. See, जे काही इलेक्ट्रॉन्स त्या मेटल सरफेस मधून बाहेर पडतायत त्या प्रत्येकाची कायनेटिक एनर्जी कशी असणार आहे, वेगवेगळी असेल. आणि ते का आहे, कारण की द रिझन फॉर दिस आर मेनी फोल्ड, म्हणजे त्याला वेगवेगळी कारणं आहेत. ऑल द इलेक्ट्रॉन्स इन अ सॉलिड डू नॉट possess the same energy. The electrons may be ejected from varying depth inside the metal surface. Again the electrons may suffer collisions before they came out the metal surface, and may others lost their energy if V, that is the potential difference between the emitter and collector plate, and the collector is at lower potential, an electron will lose its kinetic energy, it overcoming the retarding potential. That means there are so many reasons That means this emitting or the ejected electrons have the different kinetic energy, and for that there are so many reasons behind it. If the kinetic energy is not sufficient, the emitted electrons may not reach the collector plate. म्हणजे मेटल मधून इलेक्ट्रॉन बाहेर जरी पडलेत परंतु कलेक्टर प्लेट पर्यंत येईपर्यंत they need the kinetic energy, but if there are no sufficient kinetic energy they can't reach to the collector plate, and because of that there is no flow of current through this circuit. If the kinetic energy, that the maximum kinetic energy is the energy of the most energetic electrons at the emitter surface, and where its potential energy is 0, and that is the minus potential V naught, this stopping potential V naught is the stopping potential, and then this electron will fail to reach the collector, and it should be, that means this potential should be greater than this kinetic energy, where E is the electron, where this E is here, this V is the electron, and this V naught is nothing but the retarding potential. And if the electrons is ejected or just fail to reach the collector, that means it has lost all its kinetic energy just at the collector, and so that this maximum kinetic energy here is equal to E V naught, that is the stopping potential, and photo current becomes 0. Why 0? Because they can't reach the collector plate. Because of this their kinetic energy is low, and because of that low kinetic energy, they can't reach to the surface of the collector plate. And this equation then explains, that means this kinetic energy, that is the maximum kinetic energy, is equal to the stopping potential of electrons, and then this equation explains that the stopping potential V naught depends on the incident frequency and the material of the emitter and does not depend on the incident intensity. If the ejected electrons have kinetic energy, that means next point, if the ejected electrons have kinetic energy more than, म्हणजे आता जे काही इलेक्ट्रॉन्स मेटल सरफेस वरून बाहेर आलेले आहेत त्यांची कायनेटिक एनर्जी जर ही EV नॉट म्हणजे स्टॉपिंग पोटेन्शियल पेक्षा जास्त असेल तर इलेक्ट्रॉन्स कॅन रीच द कलेक्टर्स अँड हेन्स करंट फ्लो. व्हेन द कायनेटिक एनर्जी ऑफ द इलेक्ट्रॉन इज लेस than this kinetic energy, less than or equal to this V naught, no current will flow, and therefore photo current will become 0. See, from this equation we can see, from above equation tells that this V naught, that is this V naught varies linearly with, that means stopping potential varies linearly with incident frequency, and slope of straight line depends on the constant h and E, while the intercept of the line depends upon the material through phi naught, that is the work function. And suppose we take this maximum kinetic energy, which is equal to this EV naught. Therefore, using this maximum kinetic energy is equal to EV naught. Therefore, we can write equation here. This kinetic energy, that is maximum kinetic energy, is equal to, again we have the equation h mu minus phi naught. With comparing this both sides, right hand side, left hand side constant, therefore we can compare this EV naught, stopping potential of electron, which is equal to this h mu minus phi naught. Comparing this equation, we find out the value of this stopping potential here, that is which is equal to h upon E into mu minus phi naught divided by E. In this way, here we find the equation, and this above equation tells us that V naught varies linearly with incident frequency mu, and the slope of the straight line depends on constant h and E, while the intercept of the line depends upon the material through phi naught. All the above argument thus bring out the fact that the magnitude of the photocurrent depends on the incident intensity through the number of emitted photoelectrons and the potential V. म्हणजे हे सगळे जे काही आपण बघितलेले आहेत आतापर्यंतचे ऑब्झर्वेशन, या सगळ्या ऑब्झर्वेशन वरून आपल्याला काय कळतंय की ऑल द अबो आर्ग्युमेंट thus bring out the fact that the magnitude of photocurrent depends on the incident intensity through the number of emitted electrons and potential V of the collector, but not on the incident frequency. But at that time, the one thing you must remain that this mu is must be greater than this mu naught. Now see the next article, that is the last article of this chapter, that is the wave-particle duality. What is this wave-particle duality of electromagnetic radiation? All these facts related, that is these are related, that these all observations related to the experiments on photoelectric. जे काही आता आपण बघितलेले आहे ते सगळे ऑब्झर्वेशन्स जे आहेत ते कशाशी रिलेटेड आहेत की photoelectric effect. That means these all the observations related to the experiments on photoelectric effect were explained by the Einstein's hypothesis of existence of photon, or retreating light as a bundles, or treating as a light as a bundle of energy. Although Einstein gave his hypothesis in 1905, it was not widely accepted by the scientist community. And then after that, this Millikan's measured the charge of an electrons and the value of H calculated, and then match with the value given by the Planck's, and the hypothesis was then accepted. And the work function values, that is the phi naught, for the some materials were also confirmed from the given equation. Now then, Einstein and Millikan received Nobel Prize for that time for their respective discoveries in 1921 and 1923 respectively. So this theory is very important. According to Einstein's energy of radiation of frequency, mu comes in bundles with the magnitude h mu. Thus the energy of light being having n photons will having the, जर समजा एका फोटॉनची एनर्जी h mu आपण कन्सिडर केली तर n नंबर ऑफ फोटॉनची एनर्जी किती येणार आहे तर n h mu. That is, it is then possible to vary the incident energy continuously. Why we do not see individual photons? And to understand this issue, let us consider the following examples. That means the wave-particle duality of electromagnetic radiation. In its interactions with matter, here the interaction with the matter, light behave as if it is made up of packet of energy called quanta. Later, it was confirmed from other theoretical and experimental investigations that these lights quanta can have associated momentum. And hence, the questions came up whether a particle can be associated with light or electromagnetic radiations in general. That means particle nature was confirmed by Compton in 1924 in his experiments on scattering of X-rays due to the electrons of matter. And summary of this result is given. That means the wave-particle duality of electromagnetic radiation. That was the Compton showed that photon has associated momentum. See once carefully that the Compton what showed that photon has an associated momentum along with the energy. It carries all photons of electromagnetic radiations of a particular frequency have the same energy and momentum. Photons are electrically neutral. This is very important. Photons are electrically neutral and are not deflected by the electric and magnetic field. Photons can have particle-like collision with other particles such as electrons. In photon, the particle collision, energy and momentum of the system are conserved, but the number of photon is not conserved. Photon can be observed or new photons can be created, and photons can transfer their energy and momentum during the collisions with particles and disappear. And when we turn on light, they are created. Photon always moves with the speed of light. and it is never at rest. And mass of photon is not defined as we do for a particle in Newtonian mechanism. It is its rest mass is 0. These are the characteristics of the photon which is given in your book. On the other hand, here we see in the photoelectric effect what happened in photoelectric effect and black body radiation. These are the phenomena which can explain if we consider the particle nature. If we consider electromagnetic radiation as considering photon, that means the particle nature with definite quantum of energy. Also, there are some phenomena which can be explained by both theories. That means effects of wave nature of light were seen in experiments on interference or diffraction. असे काही फेनॉमेना आहेत की तिथे तुम्हाला लाईटचं वेव्ह नेचर बघायला मिळतं, लाईक ॲज अ इंटरफरन्स, डिफ्रॅक्शन. आणि असे काही फेनॉमेना आहेत की जिथे तुम्हाला लाईटचं पार्टिकल नेचर बघायला मिळतं, जसं की फोटो इलेक्ट्रिक इफेक्ट, ब्लॅक बॉडी रेडिएशन. आणि असेही काही आहेत फेनॉमेना की जिथे which can be explained by both the theories. It is therefore essential to consider the both characteristics or behaviors hold good. One dominates in some situations and other works in the rest of the situation. म्हणजे लाईटचे जे दोन्ही बिहेवियर आहेत, एक म्हणजे वेव्ह नेचर आणि दुसरं म्हणजे पार्टिकल. काही ठिकाणी पार्टिकल नेचर डॉमिनेट आहे तर काही ठिकाणी वेव्ह नेचर आहे, आणि त्यामुळे आपला दोन्हीही कॅरेक्टरिस्टिक्सचा काय करावा लागणार आहे, अभ्यास करावा लागणार आहे. अँड दॅट इज नथिंग बट द वेव्ह, दॅट इज द पार्टिकल ड्युअलिटी ऑफ इलेक्ट्रोमॅग्नेटिक रेडिएशन. अँड देअर इज thus a need to hypothesize the dual character not only for light but for the whole electromagnetic spectrum, and this phenomena is termed as a wave particle duality of electromagnetic radiation. Now, as per the Compton showed that means the photon has an associated momentum along with energy. It carries, that means these particles, all photons of electromagnetic radiations of particular frequency have the same energy and momentum. These are some theoreticals. That means here once again I repeat the characteristics of this photon. This photon can have particle-like collisions with other particles such as electrons. Then in photon particle collision, energy and momentum of the system are conserved. That means transform from one to another. But the number of photon is not conserved, because when they gave their energy and momentum to the electrons, at that time their existence is disappear. Photon can be absorbed or new photons can be created, and photons can transfer their energy and momentum during the collisions with particles and disappear. When we turn on light, they are created. Photon always move with the speed of light. These are the main characteristics of the photons, and mass of photon is not defined as we do not do for a particle in Newtonian mechanics. Its rest mass is 0 in all frame of references. And now the next article of this chapter, that is the de Broglie hypothesis. What is the de Broglie hypothesis? This gives the relation between, that means up to this we understand, that means this light has a two natures, which is called as the dual nature, and one is the particle nature and another is the wave nature. Now this scientist give what is the relation between these particle natures and wave nature. So this relation of duality is given by this de Broglie hypothesis. That is, the relation has dual nature. Matter may also possess the dual nature. That means in 1924, the Prince Louis de Broglie proposed on the basis of symmetry existing in nature that if radiation has dual nature, sometime wave nature dominates and sometimes particle nature. Matter may also possess dual nature. Normally we talk about matter as composed of particle, but are there situation where matter seems to show wave-like properties? There will become evident from the experiments on diffraction of electrons from nickel crystals. Now, as per this, de Broglie used the properties of frequency mu and wavelength lambda of a wave and proposed a relation to connect these with the particle properties. म्हणजे ज्या काही प्रॉपर्टीज आहेत फ्रिक्वेन्सी म्यू अँड वेवलेंथ लॅम्बडा ह्या कुणाच्या प्रॉपर्टीज आहेत तर त्या वेव्हच्या प्रॉपर्टीज आहे. वेव्ह आणि त्याचे कनेक्ट कशा बरोबर केले त्याने पार्टिकल्स नेचर बरोबर. पार्टिकलची प्रॉपर्टीज काय आहे एनर्जी आणि मोमेंटम. दॅट मीन्स म्यू अँड दिस फ्रिक्वेन्सी अँड वेवलेंथ इज compared with the energy and momentum. That means momentum p carried by a photon of energy E is given by the relation which is given by the Einstein, that is P is equal to E divided by C. This relation, that is P is equal to, what is the P? Momentum, which is in the terms of E divided by C. Therefore, again this E is what E is? Einstein's equation of photoelectric E is equal to h nu. Therefore, instead of this E, we can put this h nu divided by C. Again, there is the relation between this lambda mu and this C. That is lambda mu is equal to C or mu is equal to C upon lambda. Therefore, if you put the value of this mu here, C upon lambda, then C get cancelled and here the terms remain h upon lambda. Thus, the frequency and wavelength of a matter wave associated with a material particle of mass moving with velocity v are given as. Therefore, we get this equation, this mu. Again, with the help of this equation, we can make the equation mu is equal to E upon h. Rearrange only, rearranging the term. This E divided by C, again this mu divided by C. Therefore, mu is equal to what this equation? Therefore, this mu is equal to this hh get and therefore C upon lambda. Again, if we compare this equation, E divided by C, therefore mu is equal to E divided by h. Planck's constant here h, and lambda is equal to here, this lambda is equal to this h upon this P. And therefore, again this P is equal to, जसं E is equal to h nu आहे तसंच P is equal to काय आहे तर mv. Therefore, for a particle of mass m moving with velocity v, the kinetic energy is given by 1/2 mv square. Or if you want the equation for v, therefore v is equal to under root 2 ek divided by m. This is the mathematical part. Therefore, this lambda is equal to, here we are going to put the value of this v. Therefore, h upon mv, put the value of this v. Here this 1 upon v, therefore the term that is the here 2 ek divided by m. Again, this h upon m. Here we make solve this with the help of these mathematical rules, and we take this m जो आहे m स्क्वेअर केला आणि सो m स्क्वेअर करण्यासाठी आपण इथे काय केलं त्याला मल्टिप्लाय केलं आणि डिवाइड केलं. बरोबर, जर तुम्ही हा m आत आणला तर परत इक्वेशन काय होणार आहे सेम होणार आहे. हियर using that phenomena, therefore the equation remain h upon m into this under root this equation, that is the m upon 2 this ek. Therefore, lambda is equal to h upon under root this m, that is the 2m ek. In this way, here we obtain the equation for this lambda in terms of the maximum this kinetic energy for a charged particle of charge q accelerated from rest through a potential difference v. The work done, we know that the work done is given for a charged particle of charge q accelerated from rest position through a potential difference v. The work done is qv, and this provides the kinetic energy, and thus ek is equal to qv. Again, we have the equation of this ek, but we know the lambda is equal to, what is this equation? Lambda is equal to, this lambda is equal to h upon under root 2m ek. Therefore, equation here using this ek ची जी value आहे kinetic energy is equal to qv. Therefore, put this value here, and here the for electron, instead of this charge, here the charge q, here the charge e. So rearrange the terms, the mass of energy, mass of electrons and mass of charge. So MEeV. This equation become here. Again, put the values of constant. If you put the all values of the constant, then finally we find that this value of this H, that is the Planck constant, 6.63 into 10 raised to minus 34 joule. Again, the mass of this electron 9.11 into 10 raised to minus 31, 2H constant. Mass of this E 1.6 into 10 raised to minus 39, and therefore this V is not here given, and so only the terms V is not given. And solving this with the other constant terms, finally we got this lambda is equal to 1.228 into 10 raised to minus 9 under root V, where this V is in volt. This is meter. If you want this 10 raised to minus 9, that is the nano. Therefore, lambda in nanometer, here this 10 raised to minus 9 get cancelled, and therefore 1.228 under root, that is divided. This is the V into in holes. Therefore, experimentally found that electrons and subatomic particles like protons and neutrons also exhibit wave properties. Now see from this equation, experimentally found that electrons and subatomic particle, म्हणजे इलेक्ट्रॉनच नाही तर इलेक्ट्रॉन सारखे प्रोटॉन्स न्यूट्रॉन यांना सुद्धा काय असतं, वेव्ह प्रॉपर्टी असते. and the wave property of electron was confirmed experimentally in 1927 by the Division and German in America, and in 1928 by the George P. Therefore, wave particle duality of matter, that is material particle show, that is this material particle show wave-like nature under certain circumstances, and this phenomena is known as wave particle duality of matter. म्हणजे जे काही मटेरियल पार्टिकल आहे ते काही ठिकाणी तुम्हाला वेव्ह लाईक स्ट्रक्चर शो करतात, काही ठिकाणी पार्टिकल, डिपेंड्स आहे सिच्युएशन. आणि हा जो काही फेनॉमेना आहे त्याला काय म्हटलंय, वेव्ह पार्टिकल ड्युअलिटी ऑफ मॅटर. अँड दिस फ्रिक्वेन्सी म्यू and the wave number k are used to describe wave in classical theories, while mass m and momentum p are used to describe particles nature. Wave particle duality implies that all moving particles have an associated frequency and associated with a wave number, and all waves have an associated energy and momentum. Once again, see what is this? That is, wave particle duality implies that all moving, प्रत्येक जे काही मूव्हिंग पार्टिकल आहे त्या प्रत्येक पार्टिकल काय आहे, फ्रिक्वेन्सी आहे, associated with frequency and associated wave number, and all waves have an associated energy and associated momentum. We then come across the wave particle duality of matter due to quantum behavior. When we are doing the microscopic objects, that means less than 10 raised to minus 6 meter, that means small order of magnitude of H, sets the scale at which quantum phenomena manifest themselves. In this way, the wavelength associated with microscopic particle do not play any significant role in our everyday life, and we need not consider their wave nature, and also the wavelength of the microscopic particle are so small that they can't be measured. And so here we take the particle nature. On the other hand, if we try to estimate the associated de Broglie, this wavelength of moving electrons passing through a small aperture of size 10 raised to minus 10 meter or an oxygen molecule in air, it's comparable to the size of the hole through which the electron is passing. In conclusion, for both electromagnetic radiations and atomic and subatomic particles, particle nature is dominant during their interaction with matter. On the other hand, while traveling with space, particularly when their confinement of same order of magnitude as their associated wavelength, the wave nature is dominant. म्हणजे पार्टिकल नेचर कुठे डॉमिनंट आहे आणि वेव्ह नेचर हे कुठे डॉमिनंट आहे हे यातनं आपल्याला कळतंय इथे. ओके, नाउ द लास्ट पॉइंट ऑफ दिस चॅप्टर, डू यू नो दॅट इज फिजिकल वेज टू प्रोव्हाइड एनर्जी differentiate to knock off electron from the metal surfaces are as follows. First, that is the thermonic emission by heating temperature. म्हणजे वेगवेगळे जे काही एनर्जी डिफरन्शिएट टू नॉकआउट जे काही आहेत तर ते कुठल्या कुठल्या याने आहेत. तर फर्स्ट अपॉन दॅट मीन्स द एनर्जी thermonic emission by hitting the to temperature near about 2000 degrees Celsius provide thermal energy. Then next, field emission by establishing strong electric field near about 10⁶ volt per meter at the surface of metal tip provide electrical energy. Now the third, photoelectron emission, that means by shining radiations of suitable frequency, that means the ultraviolet or visible radiations on a metal surface that provide the light energy. And in this conclusion we reach that these are the different ways to provide energy differentiate to knock off electron from the metal surface. And the next, that is for your information, that is the electron microscope, which is given in your book also. That is the, do you know, we have learned about the resolving power and resolution of telescope and microscope that use the ordinary visible light, and the resolution of microscope is the limited by the wavelength of the light used. The shorter the wavelength of the characterizing probe, the smaller is the limit of resolution of microscope. That is, the resolution of microscope is better. Better resolutions can be obtained by illuminating the objects to seen by radiations of smaller wavelength. We have seen that an electron can behave as a wave and its wavelength is much smaller than the wavelength of visible light, and the wavelength can be made by such a smaller as it depends on velocity and the kinetic energy of the electrons. And electrons beam accelerated to several kilovolt of energy will correspond to de Broglie wavelength much smaller than an angstrom. That is this lambda electron, lambda, that is this lambda is less than 1 into 10⁻⁻10 meter, and the resolution of this electron microscope will be several hundred times higher than that obtainable with an optical microscope. And other advantage of this electron microscope are that electrons do not penetrate the matter as visible lights or X-rays do, and the electron beams can be more easily produced and controlled by electric and magnetic field than the electromagnetic waves. And third, that is the electron can be focused like light is focused with lenses. These are the advantages of these electron microscopes. And it was proposed in 1925 that atoms in solids can act as a diffraction center for the electron waves and can give information about the geometry or structure of solid, just as X-rays do on getting diffracted by solids. However, it took many years to realize an electron microscope for practical application, and the first electron microscope was developed by Harald Ruschka in Berlin, Germany in the year of 1929. And these are the extra information of this electron microscope. Okay. In this way, we completed this chapter, that is the dual nature. That means the chapter number in your book, that is the chapter number 14 we have completed here. That is the dual nature of radiation and matter. In next lecture we are going to start the semiconductor devices, and then we will complete our syllabus. Today we stop here.